me. I couldn't finish the whole chapter, but I did a good chunk. So I would like to give you the mic, Mark, but I definitely have prepared some questions to make it, fun and interactive. And everyone, you know the deal. Feel free to just turn on your mics and shoot questions. I can see Jack. Jack, you've been missed. Where have you been?
It's been New Year. It's New Year
Oh,
celebration.
okay.
New Year
All
celebration.
right.
I'm back. I'm back.
Good to see you. Your
Thank you.
absence was recognized.
Oh, sorry.
Oh,
All right.
certainly.
Nice to see everybody. Nice to see everybody. Thank you.
We have Saif, Joel, Vladimir, and Bahram, Jason as well. So, Joel, welcome everybody, and let's kick it off.
Okay, so what was really fun about this chapter? So the idea behind this chapter is this is a continuation of the previous chapter. So these two chapters go together, and so we took the theory that we built out on GitOps, pipelines, how these things all need to talk to each other, what IAC is, and then we put it into practice. And I will tell you, this chapter took me 3 months to write. And it wasn't because the chapter took a long time to write, but all of the code that went into it took forever to write. And so,
did you have to think about which tools you would prefer, or like, for example, Pulumi? Was this a concern if you should go to Terraform or Pulumi?
So I decided to go Pulumi because I was working on another open source project that I actually mention in this chapter called ContainerCraft. It is a project started by my friend Kat Morgan with the goal of building a VMware replacement on Kubevert. And so she started building it when she was at Pulumi and started writing it using Pulumi.
Mm-hmm.
It is a great community. It's got a Discord, great bunch of folks there talking tech all the time. And the nice thing is that it's all built on Kubernetes, and it's Pulumi is the IAC tool, and whoever just joined. Yes, thank you, muting. So I was working with her to get Open Unison integrated into the project, and so I was working with this, with Pulumi at the time. So I was like, all right, this is an enterprise book. We don't really talk about IAC tools in here. We've been doing everything in Bash. I feel like if we're doing something that's kind of big, we should do it with an IAC tool, given that that's the way you want most enterprises to do it. You don't want to really do it using just straight up Bash. As much as we all like to joke about everything's a Bash script, so that's where it came from. And I like Pulumi because I like the fact that I could use a language that I knew in Python, which also led to some infuriating moments. Because Python is Python. But the interesting thing about working with Pulumi is so the way and we dive into this in the chapter, there are two types of IAC tools out there, right? There's model-based tools like Terraform and Pulumi, where it builds this model internally on pass 1, and then in pass 2 it syncs it out. And then then you have stuff like Ansible, which I have a lot of experience with, where it's just imperative, right? Like it goes, and if there's a problem, there's a problem, right? But there's no state management. And so working with Pulumi and having to work with future values and the 2-pass system took a lot of mental gray matter for me to figure out and to get past mental blocks. And then the other issue that I ran into a lot with Pulumi was a lot of Pulumi providers are ported over from Terraform.
Interesting.
And so they don't require Terraform. Is it like it's called the Terraform Bridge, which is a terrible name because you're not running Terraform, but they take the Terraform implementation and then they create a native Pulumi implementation provider out of it. And I found with a lot of those that
making Pulumi using some sort of an abstraction layer kind of a thing.
It lost the intent of a lot of things. So like I ran into issues where if, for instance, Vault or Harbor, which both used bridges, didn't succeed, I had to tear the whole thing down and restart because the model couldn't update itself.
All right.
So
interesting.
Definitely trade-offs. All in all, I liked it. I found I've been able to adapt it to other projects, but it was definitely a bit of a trip working with the IDP or working with Pulumi and that absolutely added a long time to the implementation because, like as an example, I wrote the integrate. So when we did the secrets chapter, I wrote the code that automated the deployment of Vault in Bash. That took me a couple days to write. Translating that into Pulumi probably took me 3 weeks.
Wow. Okay.
But now that I have it in Pulumi, it's also much more reusable. So trade-off.
Yeah, I mean, for me, I would like to just share one thing here. Coming from a software background, I don't know how I should feel about this, but I'm coming from a C# background, so I worked for many years on C#. Pulumi looked like the de facto way to go make your way into platform stuff in the first place. But then I didn't want all the software concerns. I didn't want to have the same experience that you have to think about factories and all that kind of, object-oriented language problems you have into my platform experience. I ended up learning HCL altogether, and it ended really well for me. It just was still there at the back of my head to give it a try to, see how the experience is. Because I've had to do lots of comparisons for different clients in the past. And Pulumi was always coming to the table because, everyone thinks it will just make it very smooth for their software developers to end up, doing platform stuff. It is actually not that way. If your tool, I'm not saying Pulumi has issues and stuff, but just coming from your experience, if you want it to be smooth and like nicely and tightly well integrated to an infrastructure environment, I don't know. Even for me, after having a long career of software development, I felt like picking up a new language would be fine, and I did it. Yeah.
Yeah, it's some of the things that in particular just kind of I had issues with is so there was the future management where you've got to use lambdas to pull out values. And then secrets management. You can't provision a secret from within your Pulumi code. It's got to come from the outside world. So as an example,
okay.
If I generated a random token, right? So like when I was onboarding Harbor, I would generate a random token and say, this is going to be the bootstrap token. Well, I had no way to tell the Pulumi controller, hey, here's the token to use, store it in the encrypted secret state and then use that future on. So I ended up having to do multiple passes and build gates in for those passes. So that was one area. Particularly with Kubernetes, one of the things that was infuriating about Pulumi was you couldn't easily do lookups in Kubernetes. So example, again, generating random data to have as secrets for, you bootstrapping Vault, your not for Vault, but like Harbor, GitLab, everything you're expected to bootstrap with random data in a secret. And doing that pattern in Pulumi, in order to make it work, I had to do raw Kubernetes to do a lookup, create the Pulumi object and state.
Oh no, okay.
And then
that's painful.
Either based on the existing object to keep it from overwriting it, or let it work. It just once I got the pattern down, it was fine, but just really kludgy. So those would be two things that I think if Pulumi could handle would be great.
Yeah, I will stop asking questions and just because that's a very great chapter. So yeah, let's get going.
Yeah, I mean, so the first thing that's different about this from a technical requirement standpoint is throughout the book, we wanted to make it so that the only thing you needed to do the labs in this book was a VM.
Yeah.
That's it. Like we didn't want you to have to sign up for anything. Like in the first edition of the book, we actually ended up using, I built a SAML testing identity provider on our website to use with this. And people were like, well, that means I have to register with your website. And I don't really want, I'm sensitive to that, right? Like I didn't do it so that, I could get, people to spam. I did it to make it easier to use the book. And we're like, okay, we're not going to do that for the second edition. We don't want people to have to sign up for stuff. This chapter though, there's just so much stuff. Like doing it in one cluster just wasn't going to work. We actually did it in the previous two editions, and it was just too much. Plus, it didn't really show off the reality of the world where, you're not going to run one cluster with your dev and test and prod environment. You're going to have multiple clusters. And since we had talked so much about authentication and APIs, we wanted to try and build something that would look more real world.
That's certainly a real world solution, in my opinion. Very close to what we've tried at clients as well.
Yeah. So in order to do that, we ended up saying, okay, you're going to have to provision something larger. And so we actually spent the first part of this chapter talking about what can you build a lab off of? Can you build it off of something hosted in the cloud? Can you build it off of something internal? So when I first started writing this chapter, I love Civo, Civo Cloud. It's a great provider, especially if you need to spin up something quickly that has multiple nodes. I've yet to find something that you can get up and running quickly. But it got expensive for this because I had 3 large clusters running, and it was costing me some real coin to do. And so I ended up saying, okay, plus I ended up running into a problem where because this is an enterprise book, we want to do things the way enterprises do. The way most enterprises handle ingress into a cluster is they're going to hand you a wildcard cert, right? Yeah. And so we were hosting Harbor in the cluster with this wildcard cert with a self-signed CA. Civo had no way for us to be able to trust that cert. So we couldn't pull the images into the namespace once they got built.
Yeah.
So that meant I had to come back to on-prem.
Also for learning purposes, I've had, I think recently some cloud providers, especially smaller ones, might have changed their approach for free credits. In between jobs, I felt like I wanted to do a lab project on my own with hopefully a few clusters, I thought. But in many of them, I couldn't get past the stage. Even I got emails asking me the purpose of my credit ask request, and it's certainly depending on the economy I think we're in, it's a little bit of it's changing. So yeah.
The era of free everything is over. And so what we wanted to do is say, okay, well, how can you as somebody who might go through this build out your home lab as inexpensively as possible?
That's a great section. Yeah.
And so I talk about two projects here. One is Metal as a Service. So this is a project from Canonical with the idea of giving you a way to dynamically provision hardware like Metal. They also recently added, well, not that recently because I've been doing it at least 5 years, support for KVM. So I run it in my lab and I say, hey, I need a VM. It'll just provision. So like you can actually see, here's my lab back here if I can reach my camera. So like that, those servers up there, that's my lab.
Cool.
And so I personally, instead of buying I know the Optiplexes are popular. Like instead of buying lots of little boxes, I like to buy one or two big boxes and then carve them up into VMs. I find that to be easier for me. But I'm also not as big of a hardware nerd. Then you've got Containercraft Cargo. So this is the project I had mentioned earlier. That's what I eventually want to move my lab to. So this is where everything's built on Kubernetes, Talos, and Kubevert. And so that's where I would eventually like to move my lab to. So I mentioned it here too. But when it comes to the hardware, you go on eBay, and I even mentioned here, you can get a home build server, one of these things for like $500, right?
Yeah.
And especially if you're between jobs and you want to have a home lab, don't throw money at it, right? Do it on the cheap. Do it as cheaply as possible. Raspberry Pis are fun, but they don't have the horse. Like even at the 8 gigs, I know they just released a 16 gig model, but they don't have the horsepower to do real work. And a lot of the a lot of the containers are not ARM.
Yeah.
So I personally wouldn't recommend, like, unless you're like a real ARM geek. But if you're just like, hey, I want to mess around with this, I wouldn't recommend something like the Pis. So we talk about home labs, then we talk about customizing nodes. So this is why we couldn't do
Cloud.
Cloud, was because of the certificates.
Yeah.
Because in order to get Kubernetes to trust where you're pulling the image from, the node has to trust it. There's no way to provide a trust bundle to Kubernetes to say, hey, trust these certs. You have to do that at the node level. And unfortunately, a lot of it can be a little more difficult for the more inexpensive cloud-hosted ones.
Yeah.
Drivers with storage area network is another big one. So like as an example, Talos. I've been doing a lot with Talos lately. The Containercraft project works with Talos. So anyone who's unfamiliar with Talos is it's a Linux, it's a Kubernetes, it's both, right? It's 12 binaries, no underlying operating system other than bare Linux kernel, and and Kubernetes, and there's no SSH. Everything's done via APIs, and it's great. except when you need to talk about statefulness and storage, because now you have to get binaries in, right? Because how storage works, just a mount into your node. So you need something to do the mount. So like I tried to get Talos to work with my SAN via iSCSI, and that required a custom Talos image, which is easy enough to build. But then I had to create a custom daemon set with the iSCSI tools in it, and you have to do some fun. Wizardry to get the iSCSI tools into the provisioning process so that the CSI is able to do. So it's not rocket science, but you want something where the vendors are not going to go nuts, especially in an enterprise world. For this particular lab, everything is local storage, so it's not that big of a deal. So, and I even mentioned this little story with, and I've got the link here to what I had to go through to get iSCSI working with Talos. And then, here,
you need
an important note.
Yeah.
You didn't use Let's Encrypt because you don't generally use that within your enterprise. Like, it's great if you're deploying something and you just need a cert, and you can do. I do it all the time, even for stuff that's not on the internet. But for this, because enterprises aren't using Let's Encrypt, they're using a self-hosted CA. We decided to skip it.
I think that's a great point, because people take it as the de facto try to push it into their enterprise solutions. Okay, you also have the ports there. Yeah, I actually missed this bit.
This is another area where I find home labbing can get interesting. Is earlier in the book, we and I think in chapter 4, chapter 5, we talk about metal LB and setting up load balancers. I decided not to go with that in this chapter because that is just something else that you would have to get working here. And I didn't want you to have to do that. So Ingress Engine X has some great features for port forwarding where you can have a non-HTTP port attached to it. So that's what we ended up doing here, so that each cluster, we're assuming each cluster is a single node control plane cluster that's schedulable. So it makes it just a lot more compact, so we can focus on Kubernetes rather than the networking infrastructure. So this is where we start getting into Pulumi and getting things set up. We talk a little bit about Terraform and Vault.
And the change of licenses.
And the change of licenses. And why it happened. Right. No value judgments as to that it happened. Just wanted to make sure that folks were aware that had happened.
Could I interject? This is Jack. Could I interject? So I don't work with Terraform, but I work with people who do. And the fork in the road that the people I work with are taking is OpenTofu. Has that registered with you or not? Or am I misunderstanding?
Yeah, I mean, OpenTofu. So what happened was when HashiCorp announced their license change, the companies that were using Terraform as part of their Terraform as a service, so you had Spacelift, I think, is one. There are a few others. Said, okay, we're going to fork Terraform, and the Linux Foundation said we're going to host this fork called OpenTofu, and we're going to continue to maintain it under Apache 2, and we're going to add all the features that HashiCorp refused to add because they wanted to include it in their service. And so that, then HashiCorp came out and said, okay, well, we're not going to allow you to continue to use our provider infrastructure with OpenTofu. You have to use Terraform. And so it's kind of been a back and forth. OpenTofu had a lot of momentum initially. I kind of take a wait and see on it. I want to see where it is in 5 years, because maintaining a product and maintaining a SaaS solution are two very, very different things and require lots of engineering differences. And you're already starting to see a strain on these companies because now they have to maintain their own software, plus they have to maintain OpenTofu.
So therefore, explore something simply outside of that mess.
I don't want to make that recommendation because I don't,
Well, that's where you're sort of pointing to when you bring up Pulumi, right?
Yeah, I mean, I don't feel that I have enough experience with these tools to say I prefer this over that.
Okay.
What the recommendation and this is the classic senior engineer, it depends response of, you got to look at where you are. Any choice you make of an implementation tool is an investment on your part, right? Like that's the way you should always look at it. Whether you're using Microsoft for something, you're using Azure, you're using GitHub, like it doesn't matter what you're choosing. You're making an investment and you're saying, I want to know what is going to be in this for the next 5 years, 10 years, right? And that's the way you should evaluate. So if you look at it and say, well, this seems kind of unstable, there have been a lot of changes, maybe I want to stick with the generic HashiCorp and then in 5 years reevaluate and move over. Or maybe I want to look at Pulumi. I mean, Pulumi has plenty of its own issues around management maintainability, right? Like it ain't the promised land. It's its own thing. It's got its own ideas. That may or may not line up with what you want.
Okay, so to answer my question, it's not a given that people move to OpenTofu. The
I
is an
don't
option,
think so, no.
and certainly. Okay, all right. Thank you. Very good. Thank you.
I have one question about this deployment part, because I remember that you were using a local machine to install Pulumi and initiate everything from that, right? When you're working in a corporate environment, it's a question always, like a chicken and egg problem, like where you start your whole IDP, and it's like, where do you keep the state? And it's not the state just, but it's most likely how do I trigger everything and get rid of the first machine, and then Argo CD just manages everything else from that point on. Like, what was your approach, just very briefly, so I don't take much time?
Yeah, no, that's a great question. My approach was to make this as resource light as possible.
Yeah.
And so, and I didn't want you to have to sign up for anything. So I wanted to make it so that you could run it from a local environment and then talk to your remote servers. That was the assumption I was running in. But that's not very enterprisey. Like you want a controller of some kind, and you want some place to manage the state. So Pulumi,
especially if you have air-gapped environments.
Exactly. So Pulumi offers a lot of different options. They have a service where you can say, okay, we'll manage all the state and we'll manage all the releases and everything. I just didn't want you to have to sign up for it.
Yeah.
So it wasn't because it's not a great.
So there's a local state file as far as I remember.
I think it's cool. Like I love being able to visually look at it, and I just didn't want to say, hey, go sign up for something. But I think it's cool. I think it's great. The Pulumi does have an operator, so we're turtles all the way down, right? I wouldn't be surprised if you had a control plane that managed your Pulumi runs, to be able to roll this out. The other question also becomes is how repeatable of an infrastructure does this need to be, right? Like this is built as a multi-tenant. how often are you going to build this up from scratch?
Yes, that's a very good question as well, because to be able to test and test your infrastructure, and your code as well, infrastructure as code components, you have to build it from scratch. And yeah, this was a conversation we had all the time. Like, would your clusters be pets or castles even? Some suggested that we should do this once a week, like building everything from scratch. Some said, every day in the evening it should be the case, but it depends on which environment you're working on. Is this dev environment, right, or prod?
Yeah, well, and like I ran into issues with this. So, like, as an example, when you roll this out, you run the Pulumi code, but then there's a workflow inside of Open Unison that you also have to run as Bootstrap to set up resources. And I originally did not want to do that. I originally wanted to have the entire Bootstrap process to happen inside of Pulumi, inside the IAC, and then let Open Unison focus purely on onboarding. And I couldn't because there was a bug in the Pulumi provider for GitLab where you couldn't create a group in GitLab against the community edition.
Mm-hmm.
It would only work against the online edition or the enterprise edition.
And that's not what you wanted, yeah.
And that, right. And I didn't want you to have to, obviously go buy it or sign up. Like, the idea of this was to have everything running internally. So, just necessity said I had to do it that way. Because this is a multi-tenant environment, like, I get the whole cattle versus pet conversation. That's really hard to do in multi-tenancy because you have a pretty big blast radius.
Yeah.
And so it's a different conversation. I think that multi-tenancy is the way to go in the future. There's a bazillion, and I'm ad nauseum on multi-tenancy. It's something I truly believe in. And the idea of just rebuilding that over and over again doesn't sound right to me.
Mm-hmm.
Also, with storage, migrating storage is kind of a pain. Like, that's not easy. So, I feel like it's more, you need a way to build it. You want it to be repeatable.
Testable as well. Yes.
Testable, but, I don't think it's necessarily, I think it's a little too academic to say we're going to rebuild it.
We didn't end up doing it anyway in the way we discussed it in the earlier days. Like,
if you have a stateless cluster, like, the way I would put it is, if you have an environment that's simple enough that you can rebuild it every day as a way of testing your scripts, chances are Kubernetes is the wrong tool. You should probably be using some kind of a hosted provider, because you're throwing a lot of resources at a problem that's probably easier to solve with something else.
That's a good insight, actually. Yeah. Okay. Let's move on, because we still have really nice.
So here's where we dive into
bits.
The Helm setup. So again, I decided not to do this in Pulumi because the ingress controller is kind of a weird setup, and it doesn't meld well with Pulumi and the way Pulumi does Helm, because we didn't want to use a load balancer, we used host ports. So that's where you tell, and we do this throughout the book, where you tell a container like Nginx, hey, on the host that you're listening on, also listen on that host's native port. So we were telling, Nginx here, listen on 80, listen on 443, as if you were as if you were just installed on the server and running. And that was something that just didn't work well in Pulumi. And so I did it this way. If we had load balancers and stuff, you would have not had to do this step. And then everybody's thing that everybody loves so much, DNS. the source and fix for all of my problems in the world. That and time server. So you gotta set up DNS and go with a wildcard. Most enterprises, you're dealing with wildcards for clusters. You're not generally issuing a certificate for, you're not generally using something like Cert Manager to issue certificates for ingress, because that's going to violate your enterprise policies. It's not because Cert Manager is bad. It's not because Cert Manager doesn't do a great job. It's awesome. I love it. It's usually the first or second thing I install on a cluster. It's that, the book of regulations and policies that your CA has, could break a table. And you can't do that with Cert Manager. And so that becomes why you can use Cert Manager within the cluster. But when it comes to ingress between clusters or data coming in, it's got to be signed usually by a wildcard. So, wildcard is there. Then we actually get into Pulumi. So Python, you always just start with a bare virtual environment. It's, my daily driver is a Mac. I use Homebrew, and Homebrew does not let you use pip3. And it just use the virtual environment. It'll make your life easier. And then we go ahead. We set we set everything up. And this is back to what Sevi was saying with login. So Pulumi, you have to maintain state somewhere. Out of the box, that state gets managed by packaging management. Out of the box, that state gets managed by the Pulumi. Oops, sorry about that. The Pulumi. That state gets managed by the Pulumi service. Like if it just expects you to log into the service. For this, we wanted you to do it local. There's operators, S3 bucket. There's tons of different ways to do it. So you log in with that, and then you gotta, because Pulumi makes some assumptions, you got to pull the code out of our GitHub, and so it's clean. It's not in a Git repo. Then you initialize the stack, and that's where the fun really begins. Now, with the initial deployment, I added this little missive here. Eventual consistency is a lie.
That statement, I really would like to hear more about it, because that definitely caught my attention.
I'm a big Star Wars fan. The Sith are the bad guys in Star Wars. If you're not as consumed with it as I am.
I know a little bit. My franchise that I subscribe to is Lord of the Rings mostly.
Okay.
But I know a few things. Yeah.
So the Jedi have their code, and the Sith have their own code and their mirror images. So
okay.
the Sith, the first line of their code is "peace is a lie," and so I kind of take this joke off of. So there's an online account, used to be Twitter, now we're on Blue Sky, whatever, called Cloud Native Yoda. Fun.
Oh yeah, I remember.
Right, Cloud Native Jedi. And so I always joke, well, I'm a Cloud Native Sith because I'm, a capitalist. I make money, all that good stuff. And so I like to say eventual consistency is a lie, right? And we talk about eventual consistency in Kubernetes, that, you set things up and you let things eventually get there, but that's not the way it actually works, right? Like, why? Even in Kubernetes doesn't recheck webhooks. It's not eventually consistent.
Yeah. Okay.
So, and especially when you move out of Kubernetes. So, because that eventual consistency isn't really true, you got to make multiple passes for Pulumi. And that's why you have to go through multiple passes when it comes to the setup. So we start off with setting our initial values for Pulumi. And then once we do the first set, that sets up Harbor, that sets up Open Unison, that sets up all these different things that, all the initial setups, but not the Harbor, Vault, and GitLab are not configured because they're set up with these initial secrets that now you need to get into your environment. So that's when we go ahead and set the next set of things where we got to unseal Vault.
Yeah.
Not something that Pulumi will do. Then we got to set once you unseal Vault, you can only do that once and get the keys. So you got to put those keys inside of your Pulumi state. So we do that.
Mm-hmm.
And then once that's done, then we go ahead and set up the Harbor configuration. So this is, again, just getting the root password out of the secret and getting it into Pulumi. So like if Pulumi had a way for me to do this in code, it would be a lot better.
I also had to do something similar in Terraform, and I remember pulling secrets, injecting them somewhere was an issue as well, like reading secrets. So I had some scripts eventually.
Yeah, and I suspect that there are some really good reasons for it. Like I suspect if somebody from Pulumi came up, like, well, you don't want to do that because of. So it's not criticism, but it's definitely something that caused pain.
Absolutely, yeah.
And then getting back to my eventual consistency is the lie point. If I did not build hooks into my Pulumi code for these different stages, the whole thing would just fail. So like it couldn't say,
oh really? Okay.
Vault hasn't been fully set up yet, so we'll just go on to the next thing. It would just be like, Vault's broken.
Doesn't retry?
What do you want me to do about that?
It wouldn't
Nope, it wouldn't retry. Like if that first pass failed, then it would not move on to the next.
Okay, I'm surprised now.
Or like another example is, so like Vault's a really good example where with Vault, or not Vault, Harbor, you get Harbor up and running. That part's easy. But then I need to make API calls to onboard Open Unison for SSO. Well, in order to do that, I need to get a token that I generated, or that got generated for me. I didn't even generate it. And the problem with that then becomes, okay, I generated that token, but the Pulumi provider, if that token's not available, just 401s and says, I don't know, and the whole thing stops.
No. Okay.
So that's a big reason.
Yeah, I understand though. It's been a while in my Terraform experience as well, but I think you have to have a strict order of events or like the objects you provision that, if, for example, it takes longer up in your cycle, you have to wait in down below somewhere that this is provisioned on time, otherwise it would fail as well. So
Pulumi
it's not
does the same
down
thing.
To Pulumi that problem.
Pulumi does the same thing where like you have to,
I think it was different in crossplay when we had Victor Farkik doing his crossplay book. I remember it looked more like cloud native stuff in terms of eventual consistency, I mean. But it's a different tool.
Pulumi is the same way where you that was another frustration, was building a way to consistently build that out, build out that dependency list, and but even then it didn't. I could not get it to obey that list for those particular sets of calls. So we got that up and running. Then we did then we had to do some stuff with GitLab. GitLab on its own does not have great APIs for automating the onboarding. So we had to do some manual steps, fewer than in the last 2 editions, but we still had to do them. And then GitLab, my biggest complaint is that they still do personal access tokens. They don't do, they've made it so that they expire, which I guess is better. But I would really love to see them do something similar to GitHub, where you have a more permanent key, or even the ability to use like a security token service to do a key exchange. So we got to generate a personal access token.
So at this point, the only thing we have in our repository is, no, actually, we have Pulumi starting off all these, right? And everything else within the Kubernetes environment, or do we have Argo CD managing Kubernetes yet?
So at this point, we have provisioned Vault.
Yeah.
On the control plane, Vault, Harbor, Argo CD, GitLab,
yeah,
and Open Unison. And then
right.
We've also provisioned a Active Directory. And those things are all semi-integrated with Kubernetes. And then
not managed by Argo just yet. Right?
Correct.
Yeah.
And then so at that point, you can log into the control plane and you see your apps, and you're ready to SSO into them.
Yeah.
Then we deploy development and production. Development and production are much easier. The only thing that really goes on to either one of those boxes is an Open Unison. So you set up paths to their kube control configuration. You set the path to it inside of your config, you run it, and then you end up getting to, you now have a dev and a prod. But we haven't actually integrated GitOps yet.
Yeah.
So the next step is we've got to do some bootstrapping. And so where we start getting into with Argo, and then this is where we run the bootstrap. This bootstraps our 3 clusters into Argo. So it sets, at this point, Argo now has access to all 3 clusters.
Yeah.
It's talking to the control plane using its own defaults, its own service account because it's running locally. And then it's talking to dev and prod using Open Unison as a proxy.
I've seen you touch the repository structure topic a little bit, but that's a very long discussion and I don't want to go into that. Also, there are very different opinions on it. Yeah, I remember reading the fork bit about dev and prod. Yeah, I personally don't like infrastructure drift, but it's a very hard thing to manage in. I wouldn't necessarily keep it in forks, but in different folders maybe, that you have some sort of automation in between and different code owner files, etc.
Yeah, there are a lot of different ways. Acuity just came out with a new project called Cargo, also called Cargo, not the same as Container Craft Cargo.
Okay.
That is designed to make that a little bit easier to do. In the first 2 editions, we did it based on forks, and you just used pushing and pulling of forks to move everything. But that didn't really account for things like differences in host names, and so there are a lot of different ways to handle that. I've kind of gotten to the point where I like to generate Helm charts, treat them as artifacts, and then what goes into my Helm repo are value files. Like that's my favorite way to handle it.
Yeah.
And then I treat the manifest and the Helm chart as a different source code repository that isn't hooked up directly to GitOps.
Yeah. What I personally took a lot of positive outcomes of is being able to read the source code of dev and prod in single repository. Having forks usually is really difficult because forks or different branches, for example, I don't like. Normally in software development, I love feature branches and like branch-based development. But when it comes to different infrastructure environments, I don't think it works as well.
Yeah, I agree.
That's the cargo project is definitely a space where something was needed. I'm going to take a look into this. Thanks for sharing.
Yeah, I haven't had a chance to play with it. My original intent was to include it in these chapters, and I had absolutely no bandwidth to do it. I was completely burnt out by the time this was done. The publishers were
That's quite
yelling
fair.
at, we got release, get this out already. So it was too much. Maybe in the 4th edition we'll include it. But so at this point we have our 3 clusters. They're all ready to talk to each other. I did a talk at KubeCon on this back in Salt Lake City at ArgoCon on how you and yep, Sevi, what you just posted was what I was thinking about. How you actually do secure multi-cluster management with Argo. And we dive into that a little bit. And then at this point, we're ready to onboard a tenant, right? And so you go and you create the namespace. This is all in Open Unison.
What does Open Unison do? Does it create some folders or?
So Open Unison has its own built-in workflow engine. And so what we actually do is a combination of calling the APIs directly and checking things into Git.
Oh, so, nice.
Yeah, so it's a little similar to what Carlos is working on with Canoe. It's that same concept. What's different is that we mix the concept of API calls and Git where necessary, because we're not just talking to the API server. We need to onboard. We need to onboard into Vault, which is done via API. We need to onboard into Harbor, which is done via API. In theory, you could write a GitOps controller to do it, which would be interesting. But that's not something you get out of the box. And then we also launch vClusters, which is done via API as well. So it's a mix and match. We also talk to GitLab, because we're going to onboard the GitLab projects and set up all the identities in GitLab. So that too is also API call. So the workflows in Open Unison are what are doing the magic of pulling all these things together at the same time.
Nice. Okay.
And at that point you now have a tenant, my app dev, my app prod, only people with access can get into it, and we kind of walk through.
And you can create granular access permissions and controls.
And how we bootstrapped it and whatnot, and then how to promote. So there's a lot going on in this. I have one issue on GitHub that they got this up and running in GKE, but the bootstrap workflow is not working because it's not talking to Harbor. I've got to go back and redo some of this code for like the new dashboard. I've got to upgrade some things, so I'll probably attack that in the next few weeks. But there's also a video on the Kubernetes Enterprise Guide YouTube that I'll post that I actually made when right after I've got this up and running, that shows the whole process of onboarding a tenant. so you can see what it looks like at the end. So
oh, that's brilliant. I'm going to put it in the notes. Hang on. Yeah, amazing.
So yeah, it doesn't pull in everything from the different chapters. We wanted to do, like, I wanted to be able to integrate like the monitoring stack that we had built. I originally planned on integrating, and I had done this in the previous edition, integrating OPA and Gatekeeper in. I ran out of steam, but it's the same concepts.
Yeah.
But it integrates,
I mean, I remember, I think it was with Canoe, the flags you have to manage to integrate tools and having different options was immense as far as I remember. So it was like, if you want to do this, I don't remember, probably like 15, 20 tools were there already baked in. Yeah. I mean, if you want to keep going, you can keep going forever, Mark.
I could.
Adding tools. Yeah, and recipe, definitely.
I think Saifi has a question.
Actually, not a question, but I was thinking, is there like a demo for setting up OpenUnison or?
Oh, there are tons of them. Yeah. Check out our website, or even like you get to chapter 5 or 6, is the first time we automate the deployment. So, and then in chapter 8 or 9, whenever we did vClusters, we actually set up the multi-tenancy namespace as a service portal for OpenUnison. One of the things that we're doing as a company, Tremolo, is we're doing a much better job of getting the documentation onto the website on how to build these workflows. We're also going to be releasing, I call it a DocBot, where it's a LLM trained on all of our documentation, our GitHub repos, our blog posts, where you'll be able to go in and it'll just make it easier to figure out how to do all these different use cases that we've done. And then we're also building a Backstage plugin. So you can run this in Backstage as opposed to a standalone thing.
Okay,
nice. And
what's up, Jack?
Yeah. Oh, Jack has a question. I was just going to say, if you could wrap it up in like 5 minutes, we're already done with time.
If there's no time for my questions, it's okay. I can answer later.
No, please go ahead.
So first, is Pulumi like hardwired to the Kubernetes paradigm?
No.
Can I use it for just plain VMs?
Oh yeah, absolutely.
Okay, that's what I was just confirming. I live in a world where the cool kids are working on Kubernetes stuff, and the people who are working on stuff we sold to customers 5 years ago are working just in plain VMs, and like Java servers and things like that. And so the divisions between the platform layer and the Kubernetes layer are org chart differences. There's just a different team. A different team, sets of VMs, and you can put whatever you want on top of them, including Kubernetes clusters. So there's an org chart separation of concerns. So it sounds like Pulumi could fit that. So that's good. And then the next one was, I have customers who reached the point where they don't trust putting 2 vendors on the same cluster, and so using some sort of namespace multi-tenancy. So each vendor brings their own cluster. And does Pulumi and the model you just introduced envision multiple, each client bringing their own cluster? Or you really want to have a dev and a prod cluster with multiple tenants?
I'm a big multi-tenancy fan. The way that we handle that here is with the vCluster tool from Loft. It doesn't provide hard multi-tenancy from a pods talking to each other. Like, you still have to build that into your environment with like network policies and things like that. But each one gets its own API server. So vendor 1 CRDs can't interfere with vendor 2 CRDs.
Right. So vCluster is the answer. So Pulumi works with vCluster, the vCluster model. Okay.
No. Pulumi doesn't do anything with vCluster. We do vCluster here with Open Unison. I mean, vCluster is just if you go to there's a full chapter on it. I think we did the vCluster.
Yes. So I did the vCluster, but Open Unison is the new thing to me in this call. So I need to do homework on